on chapter 5 today. Maybe you heard how awesome it was from your second hour friends. I like chapter 5, but it's analytic trig, which means it's like putting algebra with trig. So, you know, I like algebra.
You know how I'm trying to copy down the
Yeah.
I got 5 of those.
Did you get them done yet?
No,
So why do you even care, Sam?
But we won't have anything from this. Like, we won't have a test for this lesson on this 9 weeks.
No. We only have this week left for the 9 weeks. So we'll definitely have a homework quiz probably this week, at least one. We're going to have a worksheet on Thursday, which we will turn in on Friday, even though it's Pi Day. Like, you'll bring your worksheet to turn in. That will go on this week. Test corrections, retests will go on this week, and Pi Day will go on this week. So those are kind of the grades that we have left. Okay, but yes, we will not have any more tests. We only have Chapter 4, Part 1, and Chapter 4, Part 2 tests for this 9 weeks. Okay? So in the last chapter, we learned about the trig functions, their graphs, and all that fun stuff. Today, we're going to review, which I already gave you the fundamental trig identities, but we're going to show how we can use them to simplify. And later in the chapter, we're going to learn how to solve equations and prove trig stuff. So it's not terrible today. There's a little bit of writing today because it's some identities, but all of these identities, I'm pretty sure we wrote out for day 1. But if you want to write them out again, I definitely would say that's a good idea. But if you have your 4 day 1 stuff and you just want to look back at that, it's pretty much the same thing. We're just going to use them more today. So 5.1 is called Using Fundamental Identities. And we're actually going to spend all week on this section because to me, I feel like it's the most important, and then we just add on from here. There are a lot of identities or theorems or formulas or however you want to think about it in this chapter. You will be responsible for learning or memorizing a lot of them. When we get to the section that I say you won't have to memorize this, I'll tell you, because I will give you some of them on the test, but not all of them, okay? The ones today, the fundamental ones, definitely are ones you need to know, which you already know. These are the reciprocal identities. Second hour, they were very confused because it said u instead of theta or instead of x. But that could be anything. U is just the angle. So if you like x better, if you like theta better, whatever you want to write there. But these are just the reciprocal. So the reciprocal of sine is cosecant. So we wrote this out. Sine of u is the same as 1 over cosecant of u. Cosecant of u is the same as 1 over sine of u. Right? And if you feel like, I know this already, I'm not writing it down, I'm okay with that. You just got to know them. So cosine of u is 1 over secant of u. Secant of u is 1 over cosine of u. Tangent of u is 1 over cotangent of u. And cotangent of u is 1 over tangent of u. Again, not like earth-shattering here. Noah's not in here anymore, but you should tell him I finished Breaking Bad. So. Yeah, it's very hard not to know how it ends, especially when it was ending when I was just watching it, but it's good. You should watch it. I am. I'm only in season 2, though, so don't ruin it.
You need to get caught up.
I can't. It's.
Wait, do you have Netflix?
That's why I'm watching it.
Just watch it all in one night. It's not that bad. I got through it. I got through the first 3 seasons.
Okay, well, I can't watch it until my children go to bed, which means I don't usually start it until like 9:30, which only gives me 1 episode, so. Yes.
Have you ever watched Bob's Burgers?
I think we watched it one time, and it wasn't really my cup of tea. So. Can I go?
What you do is you pull an all-nighter.
I can't. I have children. I have children.
Yes, you can.
I have children on the weekend, too.
You can watch it on the weekend or during the weekday. Who cares if you have like a job or children?
Bob's Burgers has everything. Well, it's like some family morals, you know, and family can watch it with you.
Remember that tangent and cotangent we can also write in terms of cosine and sine because tangent is y over x. So we can write tangent as sine of u over cosine of u, and again, u is just an angle, which means cotangent we can write as cosine of u over sine of u. Right? Remember writing this out a few weeks ago? 4-4 day 1. They told me in second hour I printed out your 4-4 day 1 notes, so maybe I didn't make you write this out. Probably a 2 hour day. We also talked about these Pythagorean identities, and in 4-4 day 1, I showed you these, and I said not really that big of a deal right now, but in chapter 5 they will become a big deal, and you will see today on the examples that we do, over half the examples we're going to come back and pull from these Pythagorean identities. They're called the Pythagorean identities because you could prove them using the Pythagorean theorem. You don't really have to know that. You just have to know them, which means these are the one thing that I think you have to memorize today of all the stuff, because all the other stuff is pretty much you know already, I think. You should know. Notice when you square a trig function, you put the square next to the trig function, not next to the u. And just remember, these are equations. So even though I write this as sine squared plus cosine squared equals u, do you agree or disagree that that would also be the same as saying like 1 minus sine squared of u equals cosine squared of u? Are those two equations equal to each other? So you're going to see these in lots of different forms, because as long as you add or subtract to each side correctly, like it's the same thing. Like on this one, could I subtract tangent over it? Another thing, I could say that 1 equals secant squared minus tangent squared. Right? Like that's the same thing, because you're just doing the algebra. And so I memorize these, and then if I see something later in my head, I think, what kind of algebra could I do to make that equal? And you'll see what I mean by that in a minute. You okay with that one? Oh, that's right. Okay. These, I kind of erased all these. These are all the cofunctions, and we wrote these out in 4-4 also. And just really quick before you start writing and stop listening, these are just saying that complementary angles, cofunctions of complementary angles are equal. So like, we know that the sine of 30 degrees equals the cosine of 60 degrees because sine and cosine are cofunctions, and because 30 plus 60 adds up to 90. I just wrote it in terms of pi halves instead of degrees. But this is just saying if you see the sine of pi halves minus some angle, it's the same as the cosine of that angle. And the cosine of something, pi halves minus some angle, is equal to the sine of that angle. I'll show you an example in a minute where we use this. You just have to know what to replace this with. You got to know that sine and cosine go together, tangent and cotangent go together, and secant and cosecant go together. And again, we wrote those out in 4-4, but we haven't used them a whole lot. And even in odd functions, that's the other thing. So I'll just be quiet for a minute and let you write those out. These are odd. These are even. And then we'll talk about it. And this is it. These are the fundamental identities, and after this, we'll do examples. Treat your book a little better right there.
So was old. That's why Casper is fun. Goes.
That was really fun.
Oh, Sam, I don't know what to think about you. We do 5 and we do 6, and then we do 8. That's how we did. Well, and you got to think, a lot of chapters we've broken into 2 chapters, and so if you think about that, we did chapters 1, 2, 3, and 9 first semester, so we only did 4 chapters the first semester. We did like 2 sections of chapter P. We had a quiz from chapter P, but we didn't spend very much. I'm not counting it as a whole chapter. And then we do 4, 5, 6, and 8. So it's really 4 chapters each semester. It's just that chapter 4 was really long because, it was all the trig stuff, which is why we don't do it in first semester because there's not enough time to fit all that in first semester. No graphing. Analytic means like algebra, so no graphing, but there is proofs. So you gotta trade off there. There are proofs. I mean, even in odd functions, remember from the test that you just took maybe about odd functions. The definition of an odd function is when you plug in a negative value, it makes the whole function negative. All of the trig functions are odd except for cosine and secant. And that's why when you plug in a negative number for cosine, it's not the opposite. It's the exact same. And if you think about cosine's graph, remember that it starts like this. Like that's what cosine looks like. It's the same on both sides. So if you plug in a positive angle, you get the same thing when you plug in a negative angle, which is why that is positive as opposed to all the other ones like sine. Sine, this side goes up, this side goes down. So whatever positive angle you get the opposite value. So that's what it means to be even and odd. I always think about like x squared is an even function. So it looks like this, where it's the same on both sides. X cubed is an odd function where you get the opposite. Okay? And again, we just want to know these to be able to simplify. All right, so the first part of your homework today isn't even really using this. It's just going back to the triangle stuff and just reminding you how to do that. So let's do one of those examples, and then we'll jump into the identity stuff. Everybody okay with that? So it says, use the given values to evaluate the remaining trig functions. So just like we did in chapter 4, they can give you a trig value and they can tell you something else about another trig function, and you should be able to figure out where you are, like what quadrant you're in, and you should be able to draw a picture and tell me what the remaining sides of the triangle would look like. If they tell you that secant of x equals 4, what other trig function do you know right away? Yeah, so you could at least get that much done, right? So if secant of x equals 4, I could say that cosine of x equals 1/4. And if cosine is positive 1/4, and if they tell me that sine is positive, what's the only quadrant where sine and cosine are both positive? Quadrant 1. If they're not both positive, figure out what quadrant you're in, because you might have a negative side of your triangle. But since these are both positive, I could draw a little triangle here. Since they're calling this x, I'm going to call it x instead of theta. And I'm just going to label my triangle. Cosine is adjacent over hypotenuse. And can we solve for the third side? Memories of this? We just did this. Chapter 4, Pythagorean theorem. We actually kind of just did this with our inverse trig stuff on the last test. So this would be like 4 squared equals 1 squared plus b squared. 16 minus 1 is 15, which means if I'm in quadrant 1, that's going to be the square root of 15. And if you can draw a triangle and you can find the third side, all you're going to go do is do SOHCAHTOA there. Like just find all the other trig functions, simplify as needed. So sine would be square root of 15 over 4. Tangent of x is opposite over adjacent, which would just be square root of 15. I hope we're getting better at simplifying our radicals. For me, at this point in chapter 5, when I do cosecant, I don't even write it as 4 over radical 15, because automatically I know to move that radical up, that's going to be 4 radical 15 over 15, right? 4 over radical 15. And for cotangent, that's going to be 1 over the square root of 15, which means that would be square root of 15 over 15. And that's it. You're just figure out what quadrant you're in, draw the picture, find the missing sides. 2 of your homework problems are that today. You could have done those 2, Colton. Colton took his test second hour, and then he came back in right when the homework was on the board, and he acted like he needed to write all the homework down because he was going to do it all before class today. And then he got mad at me when I kicked him out of class. And he said, I haven't even looked at it. I don't even know why he was trying. Just to drive me crazy, I think. stuff. The directions today on your homework, or most of the homework, say simplify. And simplify means use those trig identities to try to condense this down to something simpler. And that's why I have a lot of examples today, because there's lots of different ways to do this. And it's just one of those things that the more you do this, the more that you're going to think, oh, I can cancel this out. Oh, I can do this. And I have to say, one of my favorite things in math is crossing things out and canceling things out, which might be why I enjoy this so much, because you get to cancel things out. I don't know why I get so happy doing it, but I do. So let's see what we can do here. This is just a weird theta. I don't know what font I was using when I wrote this, but that's really just a theta sign. So don't be thrown off by it too much. If you have something outside multiplied by a parenthesis, do you agree, like if this was numbers and x's, we would just distribute that in? Yes? I'm just going to distribute here with my trig functions. So if I take sine of x times cosecant of theta, sorry, use x's here. I'm just going to write that. Sine of theta times cosecant of theta minus, what do you think sine of theta times sine of theta is going to give you? What if this was x times x? What would you get? So what do you think sine of theta times sine of theta is? Sine squared theta. Sine times sine is sine squared, just like x times x is x squared. And again, notice you square the sine, you don't square the theta. So that didn't get us very far, did it? Now we want to go back to those identities. Since this is sine and this is sine, let's look at cosecant. Is there something we can replace cosecant with that has sine in it? What does cosecant equal? What's the only thing we have on our paper about cosecant? Cosecant is the same as 1 over sine. What if I wrote this as 1 over sine of theta minus sine squared theta? And again, I can do that because I'm just replacing it with what it equals. It's like a substitution. And what's going to happen when I take sine of theta times 1 over sine of theta? And does it make sense when you take a trig function times its reciprocal that it should always equal 1? It's the definition of a reciprocal. A reciprocal is when you multiply something times its reciprocal that you get 1. And so if you can tell me that this is 1 without writing this step, I'm okay with that. But today you might want to write that step just to help you. Which means this is the same as saying 1 minus sine squared theta. And now the only identity that I gave you today that has squares in it is those Pythagorean identities. So look back at your Pythagorean identities. What Pythagorean identity do we have that has sine squared in it? And this is what I call my brain work here, which you're welcome to write to the side or write underneath here. But we have an identity that says sine squared theta plus cosine squared theta equals 1. Can we do some sort of algebra here so that we could make it equal 1 minus sine squared? Or sometimes people just see it, sometimes people don't see it. So I try to explain it the best I can. But like looking at this, could I subtract sine squared over to this side and I would get that cosine squared theta equals 1 minus sine squared theta? Ready with me on that? And so again, you've got to remember that those Pythagorean identities are just equations and you're allowed to move stuff around. So could I just replace all of this and say that's the same as cosine squared? Does that look like a simpler answer than what we started with? If you can take something that has multiple trig functions and get it to one trig function, that's definitely a simplified answer. They're not always going to simplify to one trig function, but a lot of times they do. Odd answers, definitely check your answers in the back so that you'll know, like a lot of times, especially on this first assignment, you'll leave your answer like this because you forget about that Pythagorean, but then if you're checking your answers, then hopefully that would tell you to go back and do that. Yes, dear. This sine squared plus cosine squared, right? Like, I could do one other step in here if you wanted to, I guess. Right? Like this is the Pythagorean identity. Sine squared plus cosine squared equals 1. So I just did the algebra, but we could do a substitution. If this equals 1, could I replace 1 with sine squared plus cosine squared? See that that's another way to do this? So you could do that. You could, just like up here we replace this, we could replace 1 with sine squared theta plus cosine squared theta minus sine squared theta, and you see that the sine squares are going to cancel out. Does that make any more sense than the other way? I don't know. But it comes from those identities, the Pythagorean identities. We're going to use them again in a minute, so tell me if you have more questions when I do the other one. Okay, because that's the new part, really. How about this one? Cotangent of pi halves minus x times cosine of x. You cannot start canceling out trig functions if they don't have the same angle here. So you see how these all had thetas? That's why we could work with them. When I see something that has subtraction in it and this one does not, it's a problem, which means step 1, do we have an identity that says this equals something? So only identities I gave you that had subtraction in them. The co-functions. Cotangent of pi halves minus x equals tangent of x. That's what you need to know from those identities. You have to know which ones go together, and when you see something like this, you got to know to be able to plug that in, which is why it's nice to have those notes today to go back and look at. Because now, if we have something like this where they both have x, now we can try to rewrite them and cross something out. Cosine, we don't have many options to change cosine to. We could change it to 1 over secant, but that's not really going to help us much. What about tangent? Could I change tangent to something that would help me maybe cancel out a cosine? Yeah, tangent is the same as sine of x over cosine of x. And then look what we get to do. Cross them out. Which means that ugly thing that we started with is the same as just saying sine of x. And really, why are we doing this? Not just to make you go crazy. We're going to solve equations. Wednesday, we're going to solve equations, and you got to be able to simplify stuff in order to be able to solve the equations with trig in them. So that's why today we're just practicing with simplifying. What else can we do? Because today is the first day that you've ever worked with these kind of trig functions, some of the directions today are going to be specific, like factor and then simplify. So they're trying to give you a hint on what to do. Eventually there won't be a hint, but it's trying to give you like a step to do on this. And honestly, on this one, there's other options besides factoring, but we're going to factor just so that I can show you the technique here. And I always say if you get stuck on these, change your trig functions to x's and y's, and it'll make it easier for you to know what to do on this. So if you don't see here what you could factor out of both of these, think about if you changed your sines to x's and your cosecants to y's, that would be like saying x squared y squared minus x squared. You could pull out an x squared, right? So if you get confused, that's my go-to thing of saying change it to x's and y's. Yeah, these both have a sine squared x in them, so you can factor that out front just like you can factor a 2 out front, or just like you can factor an x squared out front. You can factor out a sine squared x, and then you just write what's left over. And if you take sine squared x out of this first one, we're just left with cosecant squared x. And what am I left with if I take out sine squared from sine squared? Yeah, the whole thing's gone, just dividing, so we're left with minus 1. Factoring is a really good method for simplifying because now we have separate stuff. We have our sine squared x, and then we have this. And again, when I see a squared function and I see a 1, I automatically go to my Pythagorean identities because they all have 1 in them and they all have a squared one. So what's the one that has cosecant squared in it? What's it say? And I just changed the x's because that's what I'm working with. Right? This is the identity that you have to know. After doing today's homework, I hope you're getting more familiar with them because it's going to show up over and over again. And again, you have 2 options here. One option is we could substitute in. The other option is that you can look at this and think about what algebra can you do to make this match done here. You with me on that? I like that method, but if you want to substitute in, we can substitute in. So for me, I'm like, well, I need to subtract the 1 over. If I subtract this 1 over, do you agree that I now have cotangent squared equals cosecant squared x minus 1? And so if you can move this identity around to make it fit what's up here, you can just do a direct substitution. If you don't want to do that, you could substitute in for cosecant squared and say that's 1 plus cotangent squared, and the 1s will cancel out. Like, both ways work. It's just whatever makes most sense. But for me, I'm like, ooh, that matches. So can I substitute just cotangent squared in for all of that? Questions on where I'm getting that from? Because that seems to be the confusion step of the day.
It's like in the original equation, you have sine squared x, and then at the end you have minus sine squared x. So wouldn't that just like completely cancel out? Because it's like sine minus sine. So then it's like,
You mean like up here, could I just subtract this from this?
yeah, never mind.
Okay. It is because it's with the cosecant squared, that's why. Okay, so good news is I think this looks better than this already, so we're going in the right direction. And then the hard part, the part that's going to be harder for you on the homework is because I'm not here to kind of nudge you in the right direction, is you got to think, what can I do now? We want to make it simpler, so my advice is never take something that doesn't have addition in it and put addition in it. So don't change this using your cosine squared plus sine squared equals 1. Like, let's not go there. Let's see if we can substitute in something that maybe we could cancel something out. So, this is cotangent squared. Forget about the squared for a minute. What do I know about cotangent? It's 1 over tangent. What else can I say cotangent is? Cotangent is cosine of x over sine of x. Yes? But this is squared. But this is an equation. So what do you think happens? If I square this side of the equation, could I just square these and say that that's also the same? And again, I'm not making these things up. I'm just using the rules of algebra. That's what it means to do analytic trig. We're taking trig, and we're throwing in some algebra, which means if I have an equation that's true, I can square both sides of that equation, which means I can simplify this and say cotangent squared is the same as cosine squared over sine squared. Which means that is the same as just saying cosine squared x. This is what they said last hour, and then I showed them the next one, and then they changed their mind. So, or maybe it's the next slide. Like it was all like, this is all it is. I like this, and then it was like, this is stupid. So, let's see if we get there. Oh yeah, it was this one. Because that's what after this one, it was said, oh, this is all we're doing. This is great. And then I showed them this one, and it was, this is awful.
This might be a little
It's totally a use substitution problem. Colton, you're on fire today. I almost did, but I don't think Precal wants me to sing. In my ECA lab class, anytime they get something right, I sing, "This boy is on fire!" And we played a game on Friday, and every time they got it right, I would sing that song. And it got really annoying, but 4th hour hates it. 5th hour, I didn't do it today, and they're like, "I got it right, sing the song." I think I'm just doing tricks for them now, So Colton saw that we can do use substitution, but a lot of times people don't see this right away. Do you agree that there's no common factor that you could factor out of this one? Like over here, they both have a sine squared that we could factor out. This one, they don't. This, to me, looks like a trinomial. Like, what if this said x to the 4th plus 2x squared plus 1? So instead of having tangent in there, what if I change it to x's? So you see where Colton's going with his use substitution now? think on this one, if we wanted to do a u substitution, we would say that u equals tangent squared x. And so the reason I picked this one is I wanted you to see that you can factor using trig functions. And again, my advice is either change it to a u or just change it to x and then go back to your trig function at the end. But if you make u equal tangent squared, this becomes just a quadratic. Like this becomes u squared plus 2u plus 1. You could have also factored it from up here, like x to the fourth would be x squared and x squared, or however you would do that, but that's okay. We'll go this way. You guys are good u people. Mr. McClure must have done a great job teaching you substitution last year. I don't like u substitution that much, but this one's not so bad to factor. What multiplies give me 1, then adds give me 2, plus 1 and plus 1, right? But don't forget, u substitution is just like an in-between step to help you. I don't care what u is. I want to know what the actual function is. So you have to go back and plug in for your u. So don't forget that. Don't leave this as your answer. Go back and tell me that that's tangent squared x plus 1 times tangent squared x plus 1. Does that equal anything, tangent squared x plus 1? I think it's like a Pythagorean. What does tangent squared x plus 1 equal? Secant, like it's actually how we wrote it out. 1 plus tangent squared equals secant squared. So can I just say this is secant squared x times secant squared x? And if it's secant squared times secant squared, that's really just secant to the 4th x. They hated this one. Like, this is when I lost them. Not usually, but
He's making me feel really dumb because like, oh my
he's
God,
like he's on fire today. We'll talk about that tomorrow. The ones on your homework today with the factoring, we'll talk about tomorrow. But just know you can factor, okay? What else could we do? What if they give you something that you need to like multiply out? Let's do a couple more. I know there's a lot of notes today, so bear with me. We're getting close. I think these might be the last two. Don't pull. I know. And I think it was the last one, if I remember correctly. I think I remember. But I don't. And again, the directions today will say multiply out, then simplify. What are you going to do if you have two parentheses times each other with addition? How do you multiply that out? FOIL, right? Or distribute, however you want to think about that. You might also notice, I'll work this one all the way out, but do you see how these two are the same parentheses except for one's a plus and one's a minus? So what should happen? It's not just going to equal 1. What happens if you have like a plus b times a minus b? Let's just multiply it out, see, I guess. Oh, kids. It is the difference of squares. Hallelujah. Someone knows what I'm talking about. Been doing that since algebra 1, kids. Cotangent times cotangent is cotangent squared. If I take cotangent times negative cosecant, I'm going to get negative cotangent x cosecant x. And then if I take cosecant x times cotangent x, that's going to be plus cosecant x cotangent x. The idea is if you have the same thing except for a minus in the middle of one of them, these middle two terms should always cancel out. A plus b times a minus b will always be a squared minus b squared. That's the difference of two squares, which means if you notice that, do that part. And then cosecant times negative cosecant, I'm going to write on here, is negative cosecant squared x. And so when I multiply that together, I get cotangent squared x minus cosecant squared x. And again, when I see those squared ones, I need to look back at my Pythagorean identities. And I think I have one that has cosecant and cotangent in it. My little sidebar here. I think it says 1 plus cotangent squared equals cosecant squared. This one's a little bit trickier to solve for. Just got to move some stuff around. So again, you got two options here. I'll do both options and figure out what to do. One option is, if cosecant squared equals this, could we replace this cosecant squared with this whole statement 1 plus cotangent squared? Yeah, we could do that. The other option would be, could you do some math here using just this formula to figure out how to get that cotangent squared minus cosecant squared? And I don't care which way you do it. I tend to work with this more, but it works really well just to do substitution. So I'm going to do this way first, and then I'll come back over here. But if cosecant squared equals all of this, just doing substitution, wouldn't that be the same as saying this? Cotangent squared x. Goodness gracious. Right, all I'm doing is replacing cosecant with 1 plus cotangent squared, but I'm subtracting all of that. So you have to distribute that negative. So you would get cotangent squared x minus 1 minus cotangent squared x. And every time, if you just do substitution using your identity, just do the algebra. These cotangents cancel, and you should get negative 1 out of that. Some people just see the math, and they don't have to show these two steps. Like, some people come over here, and they say, okay, how can I get cotangent minus cosecant? Well, I need the cosecant to be negative, so could I subtract the cosecant over here? But then I need to get rid of this 1, so could I subtract the 1 over here? And that's okay, and if you can just see that if you took cotangent squared minus cosecant squared, and then you move the 1 to the other side, and you just wrote that, I'm okay with that. It's just however you see it. I don't care which way you do it, as long as you can see that I'm using the identity. And negative 1, that big ugly thing is just negative 1. What do you think about that? Multiply that out. I know, you're doing a good job. Right, it's the last day. Probably you should schedule 2 periods. Unless you're just going to stay here forever after school on Friday. Make me stay here forever after school on Friday.
And now we calculated.
Notice this is just like this in that it's the difference of 2 squares. If you notice that, you should be able to say, I only have to take 9 minus this times this, which is 9 sine squared x. If you want to work it all out, cancel out the middle terms, you can, but you shouldn't need to do that. So some people say, well, this is all you can do because you can't use the Pythagorean identity because there's a 9 in there and there's not a 9 in the Pythagorean identity. False. What can you do?
Okay, since that one has sign, it could just be,
Can I just factor a 9 out? I think I want to factor a 9 out. If you just change it to a 9, then you'd have to multiply sine squared and cosine squared by 9, which I don't think is going to work out as nicely. It might be alright, but I think factoring is a better choice. Can you use your Pythagorean identity to tell me what 1 minus sine squared is? Because sine squared plus cosine squared equals 1. So if I just subtract sine squared over, is that just cosine squared? And I promise you, as many times as we've done this on our notes today, you're going to do that a lot of times on your homework today, that this will get easier and you will recognize it more when you see it. Like soon you'll just see this and you won't even have to go back and look. You'll just automatically know to write 9 cosine squared x. I always think it's important to stay up on your homework in this class, but I cannot stress enough how much you've got to stay caught up on your homework, because every day this stuff's going to get more complicated. Like tomorrow we're going to do the same kind of stuff only with fractions, so we're going to have to get common denominators with trig and all that fun stuff. You got to be able to do this. So your homework for today, and yes, there's a lot of them, but some of them are really easy and really simple steps, like you only do one thing and multiply it out. Some of them are harder, and I'm sure that we'll look at a few of these tomorrow together that will kind of lead us into tomorrow's notes. Tomorrow's notes are shorter, but they are harder problems tomorrow. So try these tonight so that we can see what questions we have. If you're not doing your homework, I cannot help you with your grade in this class if you're not staying up on the homework and doing well on it. And we are definitely going to have a homework quiz, at least one this week. So stay caught up on your homework, because it's going to be your last quiz grade for the 9 weeks. I'll tell you 2 and 3 are like our first examples, which are the triangles. 5 and 6 are just directly from the identities, which means like there's no work needed. And then starting with 9 is the ones that you're going to work out. And I think the last 3 are multiple choice. So make sure you get all that down and get a good start on it and go from there. All right, don't forget about test corrections.